Hello friends. So today we will be looking at the strings related problems and what are the algorithms and technique can be used to solve the problem. Okay. So I have identified here couple of important techniques. With the help of those, you will able to solve almost 80 to 90% of the string problems. So techniques are like a sliding window technique, dynamic programming, and tries very important to solve the quite complex string problem, and recursion and backtracking. So what we'll do, we'll go one by one of the techniques and then the related sliding problem. Okay, so starting with the sliding window technique for string problem. So our approach would be, first have an overview of the sliding window, what it is and how we can use it. Second, what are the related strings problem that can be solved via the sliding window technique. Very important. Just look the problem and you should identify, okay, I should start from the sliding window technique. That should be the first start. And second, the third item would be the template of the sliding window. So once we identify, okay, this problem will solve from the sliding window technique, then what template I should write, should use to write the code faster. Okay, that's the agenda. And then at last, what we'll do, we'll look at all sort of examples, right? And then code for those examples in the sliding window. Okay, so first we'll just look at the overview of the sliding window. So what is the sliding window? So sliding window is nothing but you select some window, maybe let me just draw. Okay, okay, here. So there's the 0, 1, 2, 3, 4, 5, and 6. Okay, so I have a six boxes, right? And I want to select a window from first box to third box. This is my window. Okay, and then when I move this window, so this window size is fixed, just a 3. So when I move the windows to solve particular any given problem, so I'll just slide this window. Okay, so I'll just slide this window. I'll slide this window and look at the particular solution of a given problem if it is fine, if it is falling here. So this is a sliding window. Other sort of problem is that you have the window size is not given to you. That means you don't know what is the size of window. So this was the fixed one. So I had given a window size is the 3. Now here window size is not given, but the problem is given such a way that you slide your pointers, right, and find if it is giving you the solution. Once it is giving a solution, you move this window also if there is any extra character has been taken to find the solution, and then you find, okay, this is the window where I am getting the solution. So this is the moving size window problem. Okay, so basically, and so we have basically two kinds of sliding window problem. One is the fixed size where the window size is given, suppose the k is equal to 3 or 2, whatever. And second is that moving size, so where you don't have a k value, but you have to find the solution. So most of the string problem falls on the second kind of problem where you have a given moving size window. Okay, so we'll come back with the for this example I have noted down here. So look at what are the different kinds of string problem that can be solved via the sliding window technique. The first one is the minimum window substring. I've just noted down a couple of examples here. We'll just go one by one quickly. So minimum window substring. So what is the minimum window substring problem? You have a given a two strings s1 and s2. Okay, and then you have to find the minimum substring in s1 so that s2 characters should be there. For example, s1 is given a big string and s2 is given sort of smaller string. Now you have to find what is the minimum size of substring of s1 where S2 characters are available. So here it's S2 characters, right? So order of S2 characters are not necessarily important. So you don't have to worry for the ordering. It can be BDS, it can be DBS, or it can be SBD. And also no need to have a continuous S2 character. So it's not required that you should have a continuous S2 characters, right? So this is the first problem. We'll look at in a detail of this problem later. Second could be the longest substring without repeating characters. Okay, you have given one string, and then you have to find out the longest substring where the characters are not repeating. So, like for this example, this A and B, right? There's a two. Uh, the length of substring is two, where A and B is not repeating here. Similarly for other strings. The third kind of problem is the longest substring with k unique characters. Okay, so you have given a longest substring and you have to find out the three characters should be unique. What is the longest substring? Fourth problem could be the substring with concatenation of all words. So you have given a big string, you have given a words, so you have to find out the substring where concatenation of all words belongs to that substring. Okay, and here again the words ordering is not important, but however it should be word. It should not be like you take a characters from first word and then take a next another character from the second words. No, it should be a complete word, but ordering of words are not important. Fifth one is the count of occurrence of anagram of a given pattern. So good. What is anagram here? So anagram is something if you have a given ABC, then ABC, ACD, CAB, CBA are the anagrams. Basically, again, the ordering of letters are not important, but you have to find out the substring, basically the number of substrings where this anagram falls. So earlier problem we were finding just one substring. Here we have to find how many numbers of such substrings. Okay, so if you focus correctly on these problems, all the problems is talking about the substring, right? Here also is a substring, longest substring, uh, this is also a substring, and this is also a substring, right? So so whenever you find a problems of a string related to substring, you can try the sliding window. The first approach we should think about the sliding window. Can it be solved? Because it's a substring, right? So substring means I have to sliding from the first character to next character. Just an example here. So this example, right? So if I have to find out something from the substring, so I'll sliding from here to here to solve the problem, or from here to here to solve the problem, right? So because I have to find the substrings. So that's where the sliding window technique can be applied. So we'll quickly look at one of the example. Okay. So I have noted on this example itself. Done. Okay. So suppose this is the given string. I will call it as a S1, and you have given a string. Call it S2. It could be A, B, C. Now our job is to find a minimum length of substring where this S2 can be found. Okay, S2's character basically ABC may no need to be in order and not no need to be contiguous. Okay, so no, as I told, right, this is substring, so we'll just slide, and this is not a fixed size problem. So what we'll do, we can start from here and look at if I found the A. No, I have not found the A. Next, so not just the A. I did I find any of this character ABC? No. Move the slide it. Any character from ABC? No. Slide it. No. Slide it. No. Slide it. Yes, I got the A. Good. Okay, I got the A. Remove the A from the list. Move the slide the pointer again. H, no. Slide the pointer again. Yes, B, I got the B. Slide the pointer again. C, I got the C. Okay, now this is my last point, right? I'll say it's the R pointer. I got it. So now I need to find out the smallest window, right? So now from starting to here is the largest one. So I'll reduce the window size. So I'll start another pointer from the beginning and I'll slowly reduce, and I should not lose any of these items. So I'll keep checking again if ABC is find out. G is there, H, S, D, A. Okay, yes. So I basically found the one of the character from the S2. So that's fine. So now I can say that this is my the smallest window, right? It's easy one. Okay, so this is the a sort of overview of the sliding window. Now, what template I should follow when I'm trying to solve the window? So if you look at the first one, what I did, ABC, right? So for each of the characters, when I'm sliding on the bigger string, so I was trying to locate if I found out A or B or C, any of the characters. So what should be the easiest data structure to put the S2? So easiest one is to use the hash map, right? It's a O1 complexity to find the any of the character. So for example, I have a hash map. So it will have A and put the number, only one character. B, put the number, only one character. C, put the number, only one character. Right? So this will make life easy to reduce. There could be a possibility that I have to find A, B, and C. In that case, this A could be 2. And then when we are reducing, we'll reduce by 1. Right? Okay. So now, uh, so what we have done? So what we have done, we first created a hash map. I say it's a temp with the characters and its number. Okay, number can be anything 1, 2, 3. Second thing is that we have taken two pointer basically, a left pointer and the right pointer. What we have done, we started the right pointer and keep moving till I found all the characters. So slide right pointer, right? And there is a possibility that this characters, all the characters is not present in the in this string at all. So we have to limit, right? So the right character should not cross the length of the string. So that we can check. What next we have done? We try to uh, find the uh, characters by looking hash hash map. Yeah, this is what we try to do. Okay, and then a final step is that we move the left pointer to minimize the window. Okay, so we'll just look at I've noted down. So this is what I noted on. So this is the temp. There is nothing but this is the hash map where I'm putting the characters. Then we define the right pointer, define the left pointer, and then slide the right pointer right till I've reached to the end of the string. Find the characters from the string and then apply the logic. For us, it was to find match the characters right from the hash map. Here, depending on the questions, we'll apply the logic. Okay, and then now next we have to move the left pointer once we find out the right condition which is met. Until we find out, we'll keep moving the right pointer. Okay, once we find out, so we'll now keep moving the left pointer. So we'll see what is the condition. If condition is met, the criteria is satisfied, then we'll move the left pointer. We take out the s, we apply the logic, and then for minimum string, we'll check the what is the minimum length. But this can be vary depending on the question to questions, and keep moving the left pointer. Okay, until we find the minimum length for this example. In a similar way, somewhere is the longest one, somewhere is the the no characters at the no repeating characters at all. Depending on the questions, this logic will be varied, but the template would be same. Okay. Okay, so we'll stop here. In the next window, we'll take a example of a sliding window, which I have noted down here, and see the quickest way to solve the problem. Okay. Okay. Thank you very much.